Hi, this is Phil Harder.
And I'm Duff McLean, and we are with FunYouMentals.com. This is episode 1 in our series on calculus.
Today we'll be doing a particle motion question, a question that is common on both the AB and BC exams,
which are given every year in May.
So let's get started.
For this particular problem, we're going to be looking at the velocity of a particle moving along the x-axis from t equals 0 to t equals 8, given by this function. The position of the particle at t equals 0 is 5.
This is a 5-part question. A, when is the particle moving left? B, what is the particle's acceleration at t equals 1? C, is the speed of the particle increasing or decreasing at t equals 1? D, find the total distance that the particle traveled from t equals 0 to t equals 8. And E, find the farthest distance that the particle is from the origin over the interval from t equals 0 to t equals 8.
Well, Phil, what's the best way to get started with this problem?
Well, Duff, we need to take that function and type that into y1 in our graphing calculator. Hit y equals, type the function, and hit graph.
Phil, don't we only need time equals 0 to time equals 8?
That's correct, Duff. So let's hit window and set an appropriate window. Where it says x minimum, type -1, x maximum, type 8, y minimum, type -6, y maximum, type 6, and hit graph. That should give us a perfect looking graph.
So now what we need to do is recreate that perfect graph off the calculator onto paper.
So let's draw a y-axis and label it v of t. Let's draw an x-axis and label it t. And out here is the end of our time, which is at 8. And then recreating the graph that we see on our graphing calculator as close as we can. Here it is below the axis. At this point we have 0 velocity, and then it just is positive velocity all the way to 8.
Well, Phil, given that that's a velocity versus time graph, what's it really saying about our particle?
Well, that's a great question, and that's a key to the entire problem. Let's draw a little picture of our particle, and right here it originally says that the position of our particle at t equals 0 is 5. Right here you can see on the velocity graph it starts off with negative velocity, that is, it's below the x-axis. That means that it's going to be moving left, negative velocity during that time. Right here, of course, we're turning around where there's 0 velocity. And in this area, we have positive velocity above the x-axis, and the particle will be then moving to the right.
Excellent. So given those two graphs, we should now be able to answer all the questions.
Starting with part A.
When is the particle moving left?
Well, the particle is moving left when the velocity is negative.
And so I'm guessing we're going to have to find an exact number for that x-intercept.
That's correct. To find that, hit second, calculate the 0, and where it says left bound, choose a number just to the left of the x-intercept, like 4. Where it says right bound, choose a number just to the right of the x-intercept, like 6. And when it asks for guess, just refuse to guess and hit enter again, and it will display the x-intercept.
In this case, the answer would be 4.939, because the AP exam is looking for all numbers rounded to 3 places. Phil, that looks like a number we need to save.
Luckily, that's easy to do on our graphing calculator. Hit second, quit, then go down to the stow key, hit stow, and then alpha A, and enter. Now, anytime you hit alpha A, that number will appear.
And the perfect answer for this particular question would be the particle is moving left when the velocity is negative from time equals 0 to time equals 4.939.
Let's move on to part B. What is the particle's acceleration at t equals 1?
Since acceleration is the rate of change in velocity, what we're really looking for is the slope of v at time equals 1.
To find that on your calculator, hit second, calculate, and scroll down to number 6, the derivative, and just type 1 since we're looking for the acceleration at t equals 1. Your calculator reads dy over dx, or the derivative, equals -0.176. That means the answer to your question is the acceleration at 1 is equal to v prime of 1, which equals -0.176.
Good, that takes care of B. Let's move on to part C.